Let me give you exercise about this one. So let us first do number 2 before I give exercise. Let us first do this number. We have an alternating voltage which has 240 V voltage with 50 Hz. This is the frequency. Is connected across an impedance of Z. We have our impedance Z equal to 60 minus J 100 ohm. This is 100 ohm. So then the question is to find resistance, to find the capacitance, to find the magnitude of the magnitude of the impedance and its phase angle, to find the current following. So now, how are we going to do that? How are we going to find capacitance? How are we going to find the resistance? Remember, when we have negative here, the formula is R is the resistance and the capacitive reactance, which is R minus J XC ohm. So meaning that our R, which is resistance, now this is A, our R, which is resistance, our R, which is resistance, will be equal to 60 ohm. B, capacitance. So X, C, which is capacitive reactance, equal to 100 ohm. And you know XC equal to 1 over 2 pi FC. This C is capacitance. To make C a subject of the formula, our C will be equal to 1 over 2 pi F XC. We just cross multiply and we make C as subject of the formula. Then C is equal to 1 over 2 pi. What is F? 50 times XC, which is 100. Then C equal to, so I'm going to get, when you use the calculator, we get 1 divided by, into bracket 2 pi times 50 times 100. So now the answer is 3.18 times 10 power negative 5 farad. That is the capacitance, which is B. This is for B. Then C. We're going to see the magnitude. How do we find the magnitude of the impedance? Remember when we have Z equal to A plus BI, the magnitude of Z equal to square root of A squared plus B squared. So now what about when you have Z equal to R plus maybe minus JXC? The magnitude of Z is equal to square root of R squared plus XC squared. So now our magnitude of Z, which is the impedance, will be the square root of our R. We have R as 60 squared plus negative 100 squared. So our Z, the magnitude of Z is equal to square root of 60 squared plus 100 squared. So now the final answer, 60 squared plus 100 squared. The magnitude of Z now, its final answer is 116.5 619. And they have said to find the magnitude and its phase angle. Phase angle is the same as argument, the argument of Z. So which is the argument of Z, which is angle. So how can we find the argument of that Z? You know that tan alpha equal to B over A when Z equal to A plus BI. So from there it means that tan alpha, since our Z is R minus JXC, tan alpha is XC over R. So our tan alpha is 60 over 100. No, sorry. It is 100 over 60. Because our XC is 100. So tan alpha equal to, by 5, that's 5 over 3. So alpha is tan inverse of 5 over 3. So alpha is shift tan inverse of 5 divided by 3. So this is 59.036 degrees, approximate 59 degrees. Okay, remember, because you have a negative here, we're going to see where this Z is located on a circle by using quadrants. Our R is positive, but our capacitive reactance is negative. So they meet in the first quadrant. Since they meet in the first quadrant, the angle is the same as negative alpha. So which means that our angle is negative 59 degrees. So which means that our phase angle equal to negative 59 degrees. Then from there, that was C. We have D. D is asking the current flowing. D is asking current that is flowing. So now how do we get current? We know that V equal to current times the impedance. So which means that current will be equal to V divided by impedance. So meaning that our current will be equal to, our V, it is 240, I think. Yeah, it is 240 divided by Z. So let us express Z in polar form. So now Z will be equal to 116.619. Then CIS of negative 59 degrees. CIS of, so it will be 116.619 CIS of negative 59 degrees. So meaning that our current will be equal to 240 degrees over 116.619, then CIS of positive 59 degrees. Remember, when you have Z1 over Z2, where it is like R1 into bracket cos angle 1 plus I sine angle 2 divided by R2 into bracket cos angle 2 plus I sin angle 2. Finally, this one becomes R1 over R2 into bracket cos angle 1 minus angle 2 plus I sin angle 1 minus angle 2. So we just subtract our angles. So here it's like we have cos 0 degrees plus j sin 0 degrees. It's like we have cos 0 degrees plus j sin 0 degrees. So 0 minus 59, it becomes what? Positive. Because this word ci of angle is the same as cos angle plus I sin angle. So I'm going to find out, you know that the unit of current is ampere. So let us find out. Then I'm going to find 240 divided by 116.619. So we get 2.006. Then cos CIS of O into bracket cos 59 degrees plus J sin 59 degrees ampere. So this is the current. That's the current that they have been asking us to find. So from there, let me give you an exercise. I hope you are understanding this one very well. So let me give you exercise. Exercise number 1. The question is saying determine the resistance R and series inductance L or capacitance into bracket capacitance C. For each of the following impedance. Where the frequency to be 50 Hz. So we have A. Our A is saying 3 plus J8 into bracket ohm. B is saying 2 minus J3 into bracket ohm. So you may try this one. Then after this, there is revision exercise about complex numbers. So this is the end of the unit complex number. So we are just meaning the revision exercise about complex numbers. I'm inviting all of you to follow the revision exercise about complex numbers. May God bless you.